Hey guys, this video is going to be on solving quadratic equations by the square root procedure. And let me give you the square root procedure as it comes straight from your book. The square root procedure, or some books call it the square root property, says that if you've got an equation where you've got a squared expression, in this case represented by the x squared, that you see right here, okay? If you've got that set equal to a constant, then what you can do is you can write that as two separate equations. It's similar to what happens when we do the absolute value equations. It's not quite the same thing, but when you square something, then you make whatever that is positive. So there's actually two cases. One where x would be the positive value square root c, and then a second case where x would be the negative value, negative square root c. Okay, so we look at both of those. Sometimes we write a plus or minus and just write one single statement there. For example, just leaving it in this sort of formula type form here, we would write x is equal to plus or minus square root of c. But the one thing I want to point out to you is that WebAssign does not have a plus or minus button. So in WebAssign, you do have to write them out separate. You cannot put them together with a plus or minus because there's nowhere to build a plus or minus in WebAssign. And of course, keyboards don't have plus or minuses on them either. So in fact, the little equation editor that I've got here in this video software does not have a plus or minus either. So anytime I type something with a plus or minus on this, I will always have to type it separate, just like I did for that little rule right there, okay? So let's look at a real basic example of this rule in place. Let's say I'll be asked to solve, just like before, solve by using the square root procedure is typically the instructions. So if I had just x squared is equal to something like 25, then to solve that, I make those two equations. One would be x is equal to the positive square root of 25, which is just a 5, okay? And then the other one is going to be negative square root of 25. Now, I know we just got through doing P6 in class, so I don't want this to throw you off. That negative is not under the root, it's in front of the root, okay? So that negative does not give you an imaginary number. It gives you a negative real number, all right? It's the negative when it's under the root that gives you an imaginary. So this part of the solution is just simply a negative square root of 25, which is 5, okay? So you got two answers here, one positive 5, one negative 5. And like I said, that could be done with a plus or minus, okay? We could write that as x is equal to plus or minus 5, and you'll see it done like that in some instances, okay? So let's talk about what we've done here and what we're going to have to do as we go forward as far as the steps to solve this type of problem. All right, our first step is to isolate the squared expression. Now, in the previous problem, we didn't have to do that because what we started with was just x squared equals a constant, okay? But you may have more than that. So you isolate the squared expression, then you apply the property. This is when you create the two equations, x equals positive square root of constant, or whatever the x expression is, equals the negative square root of the constant. Once you've done that, you then solve the equations. So let's grab a couple of examples. These I've actually pulled out of the homework. I didn't write down what numbers they were, but they're both even. So probably not ones you would run across just in normally working through your book homework problems. Instructions are the same again, just solve by the square root procedure. Here we have more than just an x squared. Okay, so our first step would be to isolate the squared expression. Well, that's already done here, okay? X plus 4 is my squared expression. It's on one side by itself. So then we make our two equations, either by using a plus or minus, or by literally writing down two equations. X plus 4 is equal to the square root of 121, and x plus 4 is equal to the negative square root of 121. Again, it's very similar to what we do with the absolute value equation. It's not exactly the same. We do have the square root that's involved here, but it is similar, okay? Then from there, you're going to take that square root, which does come out to be a nice whole number there, and you're going to subtract 4 from both sides. So x is going to be equal to 11 minus 4, which is 7. And then this is going to give me, skipping a step here, sorry. X plus 4 is equal to negative 11, so x is equal to negative 15. So we've got 7 and negative 15 as our solutions there. Okay, let's do another example. I'm going to show you one where we get an imaginary answer. That's the whole reason why we go through P6 first, is because the square root procedure and a couple of other methods that we talk about in this section give you answers that are imaginary. And you need to know how to deal with those before you start working those problems. So x plus 2 squared plus 28 is equal to 0. This time we do need to move the 28 in this case to isolate the squared expression. So we're going to subtract 28 from both sides. Now that's a negative, okay? Then we apply the square root property. X plus 2 is equal to the positive square root of negative 28. And x plus 2 is equal to the negative square root. This negative, remember, is outside, okay, of negative 28. The number inside is negative this time, okay? But we still get one positive root and one negative root when we make the two equations, okay? So we'll go ahead and we'll work on that root for just a second, and then we can move our 2. The negative is going to come out as an I, and the 28 is not a perfect square, but it does have a perfect square factor, okay? 28 is 4 times 7, so I'm actually going to need a little bit more room right there. If I pull apart the 4 and the 7, take the square root of the 4, we get 2 times the I we've already brought out on the square root of 7. Do that same thing over here on the second equation, and you'll have a negative 2i on the square root of 7. That's the beauty of these, is that that part's the same on both of them, so you don't have to do a second simplifying the radical. Then subtract 2 from both sides, and since the number we just found is an imaginary number, I can't combine the 2 with that value, so I will have to write them separately. X is also going to be equal to negative 2 minus 2i on the square root of 7. And there's your two answers there. Okay, so we've got two-part complex numbers that we get for answers for that one. And that's probably about the most complicated type that you'll see of this type of problem in your homework.